Hello everyone and welcome in today's video. Today we are back with another task, and today we are going to use the method of virtual work to solve this beam. But before, let's continue to read the task which we have to solve, and according to the problem we have to determine the displacement at and slope at point C and the rotation at point A as well by using the method of virtual work. We know that EI, EA and GA is constant, and we need to account for all actions including bending, axial and shear. So without any further ado, let's continue. And as we can see from the support conditions, we can easily understand that the beam is going to be statically determinate, and therefore in order for us to solve the reactions, it's going to be easy, as we are going to only need three equilibrium equations in order for us to determine these reaction which we need. So for this case I decided to take bending moment at point B equal to 0, and by taking the bending moment at point B equal to 0, we are able to determine the value of reaction AY parametrically as shown here. Next, we take sum of forces on Y direction, and in this way we are going to determine the reaction at support B, which I denoted with By, and this is the value parametrically. And for the value of Ax, it's obviously going to be 0, as there is no lateral load acting on the beam itself. So the next step to be done is to determine the bending moment functions on the beam where do we have discontinuities. And the first cut section I decided to go with this one here, and we just have to use the equilibrium equations again to determine these functions. If we take sum of forces on y direction, we are going to determine the shear function, and then if we do the sum of forces on x, we are going to have the axial function, and then if we take sum of bending moments at the cut, we are going to be able to determine the bending moment functions at this cut or at these boundaries which we are interested. Next, the other cut, I would prefer to have it from the other way, as this is going to make things much more easier. For example, if one is going to do hand calculation, if you go back and if we take if you take the cut section from here and we analyze the right side, then we are just going to have the action coming from this distributed load. But for example, if we would decide to go with the other cut from here and to the left, then still would be correct and the result in the end would be fine. But for example, if one is solving by hand calculations, then the bending moment function would be quite complicated, as we have also the support reactions coming from there. So taking the cut from this side is much more easier approach. And then, as we did previously, we use the equilibrium equations and we determine the axial force function, the shear force function, and the bending moment function for the boundaries mentioned here. So after we do this, next we have to jump to the virtual beam, and according to the task, we need to determine the displacement and slope at point C and the rotation at point A. So for this problem, we started by determining the rotation at point A, for which we just have to apply virtual bending moment, if we can call it like that, with a value of 1. And then we just use the same steps that we used before for the reed beam, where we have to determine the support reactions and then find the functions for our actions, which are going to be shear, axial, and bending moment. So here we have determined the support reactions AY, BY, and AX for the virtual beam 1. And then we find the bending moment functions where do we have discontinuities, just like we did before. And these are going to be the bending moment functions, shear functions, and of course for axial we are not going to have any, as there is no lateral load again acting on the beam. Next, we do the same thing for the other cut, and we determine the functions which we are going to use when finding those rotations and displacements where we want. In addition, I also solved the virtual beam, for which we need to determine the displacement at joint C. Therefore, on the point of our interest, for example, point C is for the displacement, we just apply a vertical load with value of 1, and then we just use the same principle as before by finding the support reactions as shown here, and then we are going to find the functions where do we have discontinuities on the beam. So this is shown here. We determine these functions which we want, and then we can start to apply the method of virtual work. So now if we want to find the rotation at point A, we use the following formula, as you already know. And for the axial action, this is going to be 0 as there is no lateral load acting on the beam itself again. So after we integrate, this is going to be the integral which basically we are going to have, and then this is going to be the rotation at point A parametrically is going to have this value. Next, let's determine the displacement at joint C, and the same principle applies here. And for this one, I quickly decided to go with the help of software. I used MathCAD, but you can use whatever software which you want in order for you to get the results. And if we put these functions according to this formula here, we are going to be able to have the following formula for the displacement at point C. And this is accounting for all the actions: shear, bending, and axial actions on the beam. So next, let's just give some values for our parameters, and then we're going to check the results with the software to make sure that what we calculated is correct. So for example, let's say that A is 3 meters, B is 3 meters, and we have a distributed load acting on the whole beam with a value of 3 kilonewtons per meters. And if we input these parameters into the above formulas which we found, meaning here, and also on this formula, we are going to have the following result. This is going to be the rotation at point A, and this is going to be the displacement at point C. And next, if we are going to check our results with the finite element software, and in this case I used the Autodesk robot software, we can see that for this node, as depicted as node 3, we can see that the displacement on Z is going to be minus 20, exactly the one which we got from the end calculations, and the rotation here at node 1 is going to be minus 0.004 radians, which comes to say that our hand calculations are correct, and those values which were derived parametrically, they can be used in the future if we have some kind of beam like this one here. So this sums up the video for today. I really hope you enjoyed today's video, guys. If there is any questions, please leave them down in the comment section below. Thank you very much. See you on the next video.